Everyone hear me? Is the screen up? Good. Thank you, Mahesh, for the intro. And yeah, I think it probably is worth starting by reflecting a little bit on why we're here. So Java does run a very large amount of the world, but as JVM developers, we do face some challenges. One of them is that lots of people don't understand that. Lots of people not only don't understand the criticality of the JVM, they don't understand or value the kind of problems that the JVM solves. So they naively imagine they can start essentially from scratch and magically vibe code the world. That isn't going to work. So let's unpack some of these misconceptions. So since the rise of Gen AI, there's been a very widespread view that Python is the language of AI. There are various reasons for that which are based in fact, but most of them are not based in fact. The one that is based in some degree of fact is that Python is the language of data science. Python is also the language for training the smaller models that have been very widespread for a number of years. So, for example, as those of you who've read my books know, I'm fairly pragmatic. I'm not wedded to any particular technology. If I were using TensorFlow to train smaller models, not Gen AI models, but smaller models to do like classification or whatever, I would use Python. Even though there is a version of TensorFlow in TypeScript, and I think TypeScript's an infinitely better language than Python, I would use Python. Because if I have a problem with that thing, I can Google it really easily. It's just much more supported community. There are certainly things with data science that I would do in Python because the libraries are fantastic. I would consider doing some ingestion tasks in Python. How many people are familiar with Dockling? Dockling is a really nice ingestion library. It is written in Python. I tend to use Dockling to get stuff into Markdown and then let the JVM take over from that. There is a Java API. It calls a server there, doesn't it? Yeah. But yep, no, but like even better, use it through the Java API. So you can certainly integrate it with what you do in Java. However, those are different things from building applications. If you build the kind of applications that power most of the world, the kind of applications that pay our salaries, power utility companies, telcos, or whatever, that's probably, thank you, that is probably substantially written in Java. And there are very good reasons for that too, because Java is very robust. We have a lot of good patterns and practices that, around the JVM that have emerged over many years. The language is type safe, the libraries and frameworks are fantastic, and believe me, I've done lots of Python and TypeScript, and I keep running into things where you think, seriously? We solved this in spring in 2004 and they still do it this way? There are a lot of strengths. So my pragmatic point about language choice is you should use the right language for what you're trying to do. Seems very obvious, and it should be very obvious, but people are clearly not acting that way. So what if what you want to do is bring the undoubted benefits of Gen AI to enterprise software? I think the answer is really obvious, which is you do it on the JVM if you're already on the JVM. If your stack is C#, you'd probably want to do it in C#. You do not introduce a new language just to do that. Because let's think about what it means to Gen AI enable existing business applications. What it means is to take what you've got, what you've learned, the types, the domain models, the business logic, and make them work in harmony with models. So if you think about that, you've got one side, you've got your existing infrastructure and code. On the other side, you've got models. How many people could describe the endpoints by which you call an LLM? Hint, it's over HTTP. It's not in process. Your LLM isn't written in Python. It would take until the end of the universe for Python to execute a single inference. The LLM is not running in the Python process. It is an HTTP call away. And the HTTP call is ridiculously simple. Like, you can literally drive LLM calls using curl quite easily. So this idea there's anything magical about any singular stack or Python for doing, LLM-enabled applications is just bizarre and ridiculous. Because are you seriously saying that their other stacks cannot coordinate simple HTTP calls? Sure, you've got more things like the tool calling loop, and we'll come to that later, and I hope I will be able to explain to you why what we do in Embabel is way better than any Python framework. But this is not a complex integration problem which you can solve from any stack. So you should therefore be Gen AI enabling your applications using the stack that the applications are built on. Secondly, let's think about the distinction of roles. So as I said, Python is the language of data science. Data science and application development are very different things. We as application developers are not expert data scientists, and guess what? Data scientists don't know the first thing about application development. So, that to some degree represents an organizational misconception that you should give people with the wrong skill set excessive influence over building Gen AI applications. So hopefully I've encouraged you to seriously consider that you should be writing your Gen AI applications in Java, and if your managers ask you to use Python, you should vigorously push back. Interestingly, to further prove that there's nothing magical about Python, OpenClaw, which is not very relevant in enterprise but just clearly taken the world by storm, it's not written in Python. It's written in TypeScript. Which, further to my point, it doesn't matter what it was written in. It's what the person who wrote it felt most comfortable in creating a software application. There's nothing magical about any particular stack. Okay, so now when we have thought about languages, let's think about what it is we're trying to do. And I think there is a clear division, which is often underappreciated, between, on the one hand, the personal assistance scenario, and on the other hand, enterprise incorporating Gen AI in business processes. I think it's undoubtedly true that in personal assistance, Gen AI is revolutionary and amazing, right? I hope there's nobody here who's a skeptic at this point. This is something that is happening, has happened, is quite amazing for personal productivity and many activities. Most recently, we've seen, particularly in the last 3 months, incredible improvement in coding agents to the point where, no professional software developer should really be writing more than, say, 5% of their code. I'm not saying they should delegate all the design to the coding agent. I think they're poor at that. But in terms of actually writing code, this is an incredible tool that we should leverage. So by and large, in the personal assistance space, and I would extend that to include coding agents, Gen AI has been staggeringly successful. In the enterprise, it's been staggeringly unsuccessful. So why is that? What is different? The thing that is different is us. All of the personal assistance things are what we call human in the loop, right? They all involve someone who's making decisions. So how many people here use coding agents daily? So when I'm using a coding agent, I frequently cut it off. I'm watching the diffs, I'm watching its output, and I say, no, that's wrong. Don't do it that way, because it will try to take shortcuts sometimes. Or I'll say, oh, you've hard-coded this. This is clearly a strategy. Pull it out as a function. Those kind of things. So I'm in control, and occasionally it does bad things. Like my favorite bad thing recently was I had a bunch of test scripts that are written in my own DSL for end-to-end tests for the system. Currently, it had been designed so it ran all the test scripts. We were working on one particularly tricky one. I wanted to keep running it and trying to fix it until it worked. So how did it decide to do that? Well, I'm sitting and looking at my diffs, and I see that all the other test scripts have disappeared. So I said to Claude in caps, do not do this. Make it so you can run an individual test rather than delete all the ones that you want. you're not working on. So, broadly speaking, I would say in the personal assistant scenario, we're probably like 95% amazing and, 5% somewhere between not useful to like diametrically wrong. Guess what? If you're a professional software developer and you know your stack, that's not a problem. You're going to be massively more productive than you would have been otherwise. Because 19 times out of 20, you way quicker get to a great answer. One time out of 20, it's a bit like, you're a bit like a pilot, right? You might think that pilots don't do that much most of the time, but obviously they're highly trained, they're ready to step in at any point. So, and I think we're increasingly becoming like pilots. Same with, if you talk to ChatGPT and it occasionally gives you some advice that's completely off base, you can hopefully filter that out. The problem with enterprise applications of Gen AI is there isn't a human in the loop, or alternatively, the human in the loop doesn't get to say no. For example, Air Canada, a year or two ago, gave a customer a ridiculously good fare quote through a chatbot, and then made the terrible mistake of trying to go back on it. So, in that case, the human does not work for your company. And there's a legal implication of you having put something in front of that person. So this is very, very different. And it is, I think, one of the reasons that firstly, enterprise Gen AI is really hard. And secondly, many people go about it totally the wrong way, because they look at all the shiny objects, they look at all the really cool things that work in the assistant space because they have someone to bail them out, and they discover those things don't apply in business. So this brings us to Embabel. As you know, I kind of like to write frameworks. It's not my first rodeo. Little trivia point. The first GA release of Spring 1.0 was, I believe, 22 years and 2 days ago today. So it was in Spring 2004. And when we had this amazing moment a couple of years ago when Gen AI just suddenly got incredibly good, I was instantly trying to think, okay, how do you apply that in business applications? What would a framework look like? I looked at various of the frameworks out there, like LangChain, Python, wasn't very impressed. And I started writing my own framework. I initially started writing that framework in Python because actually, it might surprise you, but for probably between like 2012 and 2024, I wrote about 100 lines of Java. I wrote a lot of Scala, I wrote a lot of TypeScript, I wrote a lot of Python. So, I kind of made an almost conscious effort to broaden my experience from the JVM. And also for some of the stuff that we were doing at my previous company, Adamus, the JVM wasn't a tremendous fit. And also at Adamus, the people who loved the JVM were all closure zealots, so I couldn't read their code anyway. So I could actually read the TypeScript code that I ran on Node. So I wasn't like baked onto the JVM. And one aside I would say that is particularly important now is it is bad to have a monoculture. So, I think there was this period when the answer, like say, 20 years ago, the answer to anything was Java. And that is clearly not right. It's just as not right as the answer to anything being Python today. I would say, just 2 cents of advice. As a software developer, you should probably learn a new language at least every couple of years. And I mean, write more than hello world. Learn it to the point where you're actually quite fluent. And I think it really helps your thinking in general. So when I first was experimenting with some ideas, which are not unlike the present ideas in Embabel around Gen AI, was started in Python, fairly quickly decided that if I was going to be writing something that was fairly complex, I really missed a lot of the better structure that you get for building better applications in the JVM. I missed Spring. And also that in order to achieve most business value, it clearly made sense to me that it should not be an alien stack. It should be something that builds out of what people already have. So I switched from Python back to Java. I was actually quite rusty in Java. I'd also never written any modern Java, so like enhanced switch statements, records, all this kind of stuff was stuff I'd read about, but I'd never literally typed. And I would say within a day, I was still rusty in Java, but actually significantly more productive and happier because it actually felt that I was in an environment that cared whether I wrote good code. I've written a lot of Python. That's the thing that kind of bugs me. It's like, I don't know, Python, I can see why it has its niche, and it is more than a niche. But like everything about Python is like an insult to computer science. It's so, for example, immutability. What's that? Visibility. What's that? Well, underscore thing says it's kind of private. Underscore thing means I'm serious. I'm really going to break you if you use it. It is not something that is well suited to building large systems. So, for example, if I write scripts, I know there is some cool stuff in Java these days, like JVM and all the nice stuff in Java 25. But as I said, I'm pragmatic. If I write a script, I write it in Python. I look at the alternatives. I could use Java. I could use Bash. For scripts, Python's way better. It's a proper programming language, unlike Bash. I can modularize stuff, really convenient. So in the small, it's lovely. But if I'm going to write an application that's going to scale to thousands of lines, some things are going to happen. One thing that's going to happen is the lack of visibility and immutability will be a problem. Another thing that will happen is effectively, despite the best efforts to use modern Python with type hints and the like, effectively the application will become untyped. Because if a lot of your ecosystem is untyped, eventually there's kind of a cascade. But anyway, let's talk about Java rather than Python. So what was the motivation of Embabel? Well, I thought that the key thing to attempt to do to make Gen AI useful in business is to attack the elephant in the room. The elephant in the room is non-determinism, right? One of the key reasons it's very hard to build this stuff into reliable systems is it behaves differently. The more we run the same application, the more different results we can get. This is a pretty serious problem because if you think about the old world where our applications executed in code, there were essentially corner cases where it was non-deterministic. There were things like race conditions, distributed computing, and they took a ridiculous proportion. Right? Those corner cases actually take a ridiculously large proportion of your time and effort when you're building systems. So the fact is you've got a programming language that's supposedly deterministic, but you can encounter scenarios that are unpredictable. Really bad. So what happens if you have something that is absolutely non-deterministic? Right. How do you fight that? So the key thing to fight it is to apply a very old technique that we've done for literally forever in programming, which is decomposition. So if you want to make a big thing easy to do, break it up into lots of little things and have those little things be more focused, test those little things. So that is the single biggest thing that Embabel aims to make really easy. And of course, Embabel's not unique in this. Other frameworks enable you to do this as well. You can get structured return types from LangChain like any framework. But with Embabel, we push that very hard. So first thing, instead of, say, relying on your agent to have one big tool loop with a ton of tools, where it's at all possible, break it up into multiple steps that have very focused prompts, structured outputs, and just the tools that are relevant to them. That goes a very, very long way to making your applications more predictable. It also unlocks other benefits. So if you give your model too much autonomy, so for example, you have loads of tools, you could take a business problem, expose, say, some of your methods as tools to the LLM, and give it to Opus 4.6 or a really impressive model, and it'll do a pretty good job. But it won't do the same job every time and is absolutely useless for any business critical operation. Whereas once you break it down, you get a lot of benefits. For a start, you can now audit what's happening, right? Because you've got a flow of the types between all these individual steps. You can retry, you can apply all kinds of policies. around the steps. And also, you don't need to use a God LLM. So, if you're essentially on the bleeding edge where you're always relying on using the most powerful LLM, one fundamental problem with that is you don't own that LLM. That is running in the cloud of a large provider whom you may or may not trust. And, of the two largest providers in the US, you've got, I don't think people tend to use Sam Altman and trust in the same sentence. And on the other hand, you've got like the Pentagon almost literally at war with Anthropic, right? I mean, there are dangers in being tied in to any of these models. And you probably don't want to, go to a Chinese model in the cloud. So imagine, for example, if you break up your application into multiple steps and discover that many of them are really simple and you require a small LLM. Guess what? You can host your own LLM behind your firewall. So for example, it may well be the sensitive customer data never has to go outside. Also, of course, it will reduce your costs significantly if you're able to do that. So Embabel really emphasizes structure, and structure on the JVM obviously leads us to the idea of JVM types. And, we shouldn't, I wrote a blog post a few months ago called Don't Talk English to Your LLM. You generally should not be asking for plain text back. You should generally ask your LLM to return a structured type. In the case of Java, any Java framework will marshal. They will instruct the LLM under the covers to return the correct type. And this obviously has many, many benefits. Because, for example, you can now have return objects that you might already have. You can feed those objects into existing business logic. You can persist them. You can, log them. There's a whole bunch of great things that you can do if you take this approach. So we want to break things up into multiple steps. That begs the question of how do we orchestrate those steps? How do we know what order to put the steps in? There are various things we can do here. One is we can simply do it in code, like we can simply, invoke the LLM when we want and have all the logic in our code. The problem with that is that it is invoking an LLM is a little bit different from other things, because for a start, the LLM is going to call back with tools into our code. But more importantly, it's very slow. It's very error prone. There's a lot of benefits in like having a framework capable of coordinating and managing the workloads. So, most frameworks take the view that if you're more than a low-level framework, you need to have some kind of approach to orchestrating these steps. So the obvious way to do that is a state machine. And that's what LangGraph does in the Python world. And just briefly coming back to Python, the Python frameworks are nothing special. Like, even I would say, and I say this as someone who's very fluent in Python, I don't think any of the present Python frameworks is near the best framework you could write in Python. And it partly comes back to the question of skills. Like a lot of those frameworks were originally written by data scientists who are not the best application developers, even on Python Planet. So one way you can do the planning is you can do a state machine. Another way you can do it is you can just make it sequential, where you run one thing after another. So Crew AI does that, and they kind of have composition, so you can have sub. Alternatively, you can pretend that planning doesn't really matter and let the LLM do it, like Microsoft Semantic Kernel or the Google ADK supervisor pattern, where you basically do handoffs using tools. So you have one agentic loop and you give that access to, other really coarse-grained things in terms of tools. The problem with that is it really isn't very predictable, and I don't think it's sufficiently rigorous. So when I set out with Embabel, I didn't want to copy what was there in Python, which is why it's Embabel is its own name rather than the Python framework's name. And I would not have done it unless I felt that we could bring something genuinely novel. So, hopefully I will have achieved my objective if by the end of this evening you will feel not only that Java is a real player in the Gen AI space, but it is more than competitive. Okay, let's have a look at some code and we'll get to the actual concepts through code. So I'm going to be showing you the Embabel project. Go to its Apache license, as was Spring. As is Spring. Go to Embabel, GitHub organization, and the Embabel agent project is the core framework repo. We have really good documentation. So if you follow the documentation link, you'll find that's very nice. I think one thing that has really changed over the last 20 years is the bar has gotten much higher for open source and documentation, and that's awesome. Like when Spring first came out, most frameworks didn't have very good documentation. I think probably one of the first frameworks that had really good documentation in open source that I used was Hibernate. How many people remember the cats and kittens? Gavin had this thing about cats and kittens, and the documentation was really good and it was really helpful, and that was inspirational to us in Spring. So we always emphasize good documentation. So I've taken that to heart with Embabel, but there's also another reason why really good documentation is especially important now. Why is that? Why is it more important than it's ever been? LLMs are trained on it, and also you can do RAG on it. So for example, even your bleeding edge documentation for your latest version that the LLM mightn't have been trained on for your newest features, you can actually run, say, a RAG chatbot on it. And if you very quickly discover that if the quality of your documentation is bad, the quality of your RAG is bad. In fact, if the quality of your documentation is bad, the quality of your RAG is worse. So for example, if you've got multiple sections that contradict each other and one of them's out of date, just somehow it will always find the wrong one. So that's another reason we put a lot of effort into that, which also brings us to the fact that we have our own RAG against our documentation. You can currently run it from Docker or you can build it from source. It's 100% dog fooding. It uses Embabel and Embabel Agentic RAG on our documentation and other sources. And we are shortly going to be offering that in the cloud as well. So anyway, easy to learn the framework. But where we're going to start is we're going to start with the Java agent template. So if you're familiar with a GitHub template, this is a repo that's just easy to create your own repo from. You don't need to clone it. You just hit this magic button here and off you go. And so the very first thing I'm going to show is what you get if you do that. So here you can see that we have Maven. How many people are using Maven? How many people are using Gradle? I guess the rest. We happen to use Maven internally because we really, like all frameworks, have a pretty damn complex build. And the person who did it prefers Maven, and I had absolutely no desire to either argue with him about it or get involved in it. So, and Maven works. However, this is bog standard. This is like essentially using the Spring Boot parent, so it's trivial to do this in Gradle. So this is using the Spring Boot parent, and then you bring in the Embabel starters if you're using Spring Boot, and off you go. So very, very easy to set up, and obviously if you start with this template, you'll get that out of the box. So now we've got that, we can create a Spring Boot application, and as you can see, this looks like any other Spring Boot application. There's nothing Embabel in there, just bog standard Spring Boot. Now we can start doing cool stuff. So let's do the simplest thing we could possibly do with Embabel, because the Python people think it's easy to do Gen AI. Let's see how easy it is. So let's start with our excitingly named injected demo. So injected demo is a record. It's annotated with Spring at component, and it is injected with the AI interface. The AI interface is the gateway in Embabel to pretty much anything you want to do with a model. That includes embedding models as well as LLMs. Anywhere you've got, if you've got the Embabel starter set up, anywhere you want the AI interface, you can inject it. The interface is thread safe, so you can hang on to it because you're going to create a new prompt runner instance every time you use it.
Can I ask a question?
Yep, sure.
Can you use Embabel with outside of Spring?
You can use Embabel without Spring AI since a couple of months. In fact, we actually do have a LangChain. It's not released yet, but I think it went into our examples today of how you can use LangChain underneath. We most likely will remove all the force coupling to Spring before 1.0. We're very close. There's a bunch of people in the Quarkus team who are pretty interested in, So yeah, we've unpicked most of the unnecessary dependencies. And the really good thing is that Spring users, who will obviously be the vast majority, will never notice. Because with the starters, this experience, like anything you want, that Spring will just come in. So yes, the aim is that, like when we started out, we were happy to delegate, for example, the tool loop to Spring AI. As time has gone on, we've realized that we need total control over everything to do with how we talk to the LLMs, and also that, there's no particular need to be more deeply coupled to Spring than we want it. So most likely that will be possible as of Spring 1.0, if not probably Embabel 1.0, if not shortly thereafter. As far as Embabel is concerned, of course, you could construct the AI object differently. So now we're going to do the simplest possible thing. So we've got our AI interface. In this case, we want to use an LLM. So the first thing we do is specify what kind of LLM we want. So we have a Fluent API, which I think is really, really quite nice, and we put a lot of effort into. By the way, one of the core developers is Arjen Pietzma, formerly from the Spring team, and Arjen is exceptionally good at API polish. So we've had lots of good discussions around that. So first thing you do is you choose an LLM. That enables you to choose models by name from the set of models that Embabel knows about, and we'll get to how you configure that shortly. Well, actually, I'll tell you how you configure it. How you configure it is you bring in the relevant starters. So clearly there are a ton of models out there. You don't want every single model's connection library on your class path. So you specify the APIs with the starters that you want for, say, OpenAI, Anthropic, Llama. We support very, very wide range of models out of the box. Out of the box, we support anything that Spring AI supports, but we also have a very, very easy way of writing your own, I think it's called LLM message sender. It's 2 methods, and you can implement it for any LLM. There's a very large software company who have their own, I think it's all a bit hush-hush, so I don't know the full details, but they seem to have their own LLM that has really bizarre auth that cannot work through any, and they actually successfully implemented their Embabel connector. So specify our LLM. We can choose the LLM by name, the LLM by role, or we can provide LLM options. LLM options are serializable, so if you're using, say, application.yaml, you can put the temperature, the model name, all of those things you can externalize really easily. So we find that in some of the complex internal applications we have that are, say, using 5 different LLMs, we've externalized all of that outside Java or Kotlin code. So then we can optionally specify an ID. So this will just make your logs nicer. Otherwise, you will probably get in the log something it'll think the ID is like injected demo.invent animal. So now we specify the type that we want to create. The reason you go through, it's nice to go through this step, is everything after that is strongly typed. So here, for example, you can say with example, and you don't have to put JSON into your example payload. It's strongly typed because it knows that it's going to return an animal. And you can either render a string prompt or you can render a template, and our default templating technology is Jinja, Jinja, which is the default Python technology for templating. A word about templating. Generally, you don't need to externalize prompts. because if you do what I said and break things up into small steps, you're not having to do a great deal of prompt engineering. Prompt engineering is absolutely horrible, and it's not engineering in any form at all. Prompt engineering is basically alchemy. You're literally throwing things at the wall and seeing what sticks. Guess what? If you're attempting to do a big business process with a prompt this big and 50 tools, good luck with your prompt engineering. It may be successful, but then the model provider might release a new model and it might behave differently, and your engineered prompt mightn't work anymore. Whereas if you break things up into small steps, your prompts are nowhere near as sensitive. And trust me, you'll have a lot less pain. So in general, I don't externalize prompts. I build them in Java code. And notice, because you're building the prompt in a scope, like a method, you've got access to everything that's in scope. So you can build it in a type-safe way. Right, let's run it. So from the AI interface, you can get any LLM that is configured. And it is very easy. If you're just doing, if this is, all you need to do is add just a little bit of LLM work to an existing application. This is very easy. So the Java agent template uses Spring Shell just as a convenient way of interacting with it. Obviously, that's not something you typically do in your application, but it's actually really nice for iteration and demo. So we've got a shell command. So if you look at demo shell, this is Spring Shell component. And guess what? There's nothing special about that class. It's just injected. So all we do is call the invent animal, and it's going to do it. Okay, so let's type in animal. And the animal is a glimmerpaw of species Luminox. Okay, let's just drill into that a little bit. So if we go back here, remember we return type animal. Here is the animal record. So the animal is a Java record, and one of the things that we've found that when you follow this advice to break things up into small bits, you end up using a lot of records. Records are just brilliant for that, right? Not much ceremony. And so very often you end up with private records that are like interim results, and the framework's perfectly happy to bind private records. So here, notice it's got a name and it's got a species, but there's a JSR 303 annotation, Java Beans validation annotation on this field. So what Embabel will do under the covers is tell the LLM what the validation rules are for that field. And when it gets it back, it'll validate it. And if necessary, it will send it back and say, hey, you need to correct this. It didn't adhere to this regular expression. So in fact, even though these are here because they're a really nice example, we don't need those with examples. It will actually figure it out. Right, so let's do something a little bit more complex. Having said that, this is really quite useful. It enables you to just, one of the things in business applications that is not terribly exciting, but I think is a tremendous unlock of value, is integrations that barely work. So I'm from Sydney, and the Sydney Harbour Bridge opened in 1932. There's a really famous photo of the two parts coming together. When they came together, if they'd been, I don't know, more than a few inches apart, the whole thing would have been useless. But fortunately, they came together correctly. I think we've got a lot of systems in enterprise that are like this, where they're pretty close, but they're far enough away from each other that you need people to be making judgments about, oh, does this thing, how does this relate to that? I think these kind of really, really simple, really easy LLM usages can actually safely solve a lot of these integration problems, where it is actually, it's too subjective to go and write a bunch of Java code to safely do it. It's more than regular expressions or the things we could easily write as rules. But it's actually very easy for an LLM, and it will actually perform very well. So there's already, I think there's a big value there. And as you see, it's just as simple as putting Embabel on the class path, get your starter, and off you go. But let's look at something a little bit more complex. So Embabel is a bit different from other frameworks in that Embabel really is designed to be thought of as partly as a server. So it knows when Embabel is running in your application, it knows what your agents are, it knows what your actions are, it knows what tools are available. So it's kind of got this map of what's available to it. Let's just ask what it knows. So this is going to be essentially interrogating the agent platform. So the agent platform knows that it's got a bunch of Claude models and it's got a bunch of OpenAI models. This is because I have the relevant tokens and I have put those starters on the class path. In one thing, as I said, in enterprise, internal models can be very interesting, and there's options like, for example, LLM Studio or Olama that are really, really nice for locally hosting your models. And obviously we support them in a completely transparent way. Let's ask it what agents it knows about. In Embabel parlance, an agent is essentially a multi-step workflow, which can span multiple agentic loops and other code invocation. So here it's pretty verbose, but at the bottom it says TLDR, write and review agent. And the purpose of that agent is to generate a story based on user input and review it. So let's run that agent and then look at how it works. Do we want to see it run first, or do we want to see the code first? Okay, see it run first. Okay, so what do we want a story about? Star Wars? Well, actually, okay. Yep. Okay, so notice it did a bunch of stuff, then it paused. That pause probably indicates it called an LLM. So what it will do is typically a disgustingly heartwarming story, because LLMs are kind of possibly over-aligned. But let's see. So in a distant galaxy, a young pilot discovered an ancient star map hidden in her grandfather's attic. Guided by the Force, she faced cosmic storms and dark Sith traps. So notice it's kind of a little bit flowery and ever so slightly wacky. We'll see why that is in a minute. And we've got a review that is basically positive. But something that's interesting here at the bottom is it tells you what LLMs are used. And in this, that wasn't quite so interesting because they both ran on the same LLM. It told you how many tokens it used, and it actually told you the cost. So we maintain metadata about models if we have access to it. So for all the well-known models, we can tell you how much your costs have been, as well as how many tokens were used. The reason that is important is because you can actually even get at it within Embabel. So your agents can actually ask how much has been spent so far. So for example, you could give guidance, which an agent could consider when making tool calls based on how much usage it had done. So let's have a look at the write and review agent. By the way, at this point, obviously I'm showing you Java code, but it's worth mentioning that the framework itself is mostly written in Kotlin. And I think Kotlin is a fantastic choice on the JVM. I mean, obviously, Java is not the Java of 2005. For whatever reason, nearly everybody outside the Java community wants to, pretend that it is. It's not. It's greatly improved. But nevertheless, Kotlin, I think, is objectively a nicer language. And the interop with Kotlin and Java is amazing. I say this as someone who did a lot of Scala about 13, 14 years ago. I liked Scala as a language a lot. However, the Java interop, particularly all the collection wrangling, it was just painful. And ultimately, it did mean that I think for most large applications, it just wasn't worth it. The degree of pain you were reducing. With Kotlin, this is not the case. And what we have discovered and gradually got better at is ensuring that our Kotlin code is beautiful to use from Java. There are a few extra things you need to consider. So for example, Kotlin has name parameters, which Java does not have. Kotlin has companions like Scala, which is not a concept we have in Java where we have statics. There are just a few little extra things you've got to do to ensure your Kotlin is idiomatic from Java. But if you do those things, I think you can get to a situation where your code base is easy to maintain, yet beautiful to use from Java. So for example, the builder pattern has a good motivation, but is like really annoying in practice. You don't need that if your code base is in Kotlin. So for example, I showed you that Fluent API thing with lots of withers. They're all copy constructors in the implementing class, so it doesn't matter how many parameters that class has. I mean, it's an internal class, I don't know how many fields it has. It's just really easy, not at all error prone to support that in Kotlin. Okay, so here we are very much in Java. And the first thing I typically do when I write an agent is I think about what types that agent should have. And I would strongly encourage this as a good discipline. So if you don't think first about the LLM, think about your domain and how you would structure that domain. And this, of course, brings us to the point that, you know what, a lot of things don't change. We have to, I think, be confident in the fact that we understand good software engineering principles. They didn't just all evaporate. Sure, our jobs are changing. Our jobs are changing a lot, and we absolutely need to roll with that and embrace it. But the fact is there are a lot of disciplines, a lot of learnings that we've accumulated over decades that really matter. And, you know, these are, I think, learnings that the Java community has led the way on and really taken to heart. So, you know, I start by essentially, I'm going to decompose the problem. And I'm going to start by decomposing the problem and thinking about, like, what are the types that are relevant to solving that problem. Often when you do that, you discover something really cool, which is you've already got these types because this is a problem you already had. And you're actually adding Gen AI to handling a problem, you know, enhancing something about an application you already had. And that's like, you know, that's like where you go right around the Monopoly board. That's awesome. You collect $500. So in this case, it's pretty simple. So we have two types, which I've made to be Java records. There's the story and there's the review of the story, which seems pretty straightforward. You'll see there's a different annotation here. There is @agent. This is an Embabel annotation, but it is annotated with the Spring @component annotation. So whenever you annotate a class with Embabel's @agent or @Embabel component, it automatically in a Spring environment will get injected and managed by Spring. So for example, where did our constructor parameters come from? As you can see, these are annotated with value is Spring annotation. They're injected by Spring. Our domain types are very simple. We have two steps in this action. So it's pretty obvious if you think about how your action would, these would break down. Firstly, you write the story with the user input, and then you review the story. So we model the individual action steps in Embabel workflows as Java methods. Remember I talked about the importance of structure? Types are pretty great for structure. So with respect to ordering the actions, our approach to orchestration is different from, say, a state machine. It's dynamic. It is using an algorithm, one of two algorithms you can choose from, called GOAP or Utility AI. So GOAP stands for Goal-Oriented Action Planning. What it is a way of planning a route to a goal through action steps that are available to you. So goals have preconditions. Action steps have preconditions and expected postconditions. So therefore, it is possible to work out an ordering of the optimal ordering of actions to achieve the goal. So this is actually dynamic. Unlike, say, a state machine, which is difficult to change if you add an extra state, this is extensible without modifying existing code, and it's dynamic because planning occurs at runtime. So for example, you might have a particular action that's not available because some system's down. Maybe there's another route to get to the goal. Maybe there isn't, in which case your other system's down, but maybe there's another way of achieving the same result. GOAP is, I guess technically it is an AI algorithm, but it's a non-LLM AI algorithm, and it is deterministic. Under the name GOAP, it appeared in gaming in the mid-2000s and is one of the most popular algorithms for controlling AI characters in games. So although most enterprise developers haven't heard of GOAP, I would say they've probably actually been killed by a GOAP AI because they're very good for games. So, GOAP AIs in games will consider things like their damage level and the weapons they have available and plan a path to get to where they need to go. So normally, you don't have to worry about the defining pre and post conditions because remember I said that the action steps are methods? Well, how could we think about Java methods and pre and post conditions? Well, we could look at the parameters and we could build a world state by what we presently have in scope, which would enable us to plan a path towards the goal. So most of the time, you don't need to explicitly worry about conditions, but if you want to define your own conditions, you actually can do that. And that can be useful, for example, if you want to compute a condition, like a named condition, and say this is a precondition of something else. So the world state at any point in time consists of string names and Boolean values, and therefore all your conditions. But usually Embabel just works it out from your code. So it's going to introspect your code and work out what actions are available. So as I said, Embabel is a server. It knows about what's available to it. So this is why it needs to know about all the actions and goals so that it can plan. So the first action, if we forget that for a moment, what each step does is like completely intuitive and also very strongly typed. So we craft the story using user input. User input is just a well-known domain object. There's nothing really special about it. So we build this prompt in a type-safe way using the user input. And here we're getting the AI interface. You can either inject it at class level if you're not in an agent, but if you're in an agent, it's generally better to inject it at method level. How many people are familiar with the way in Spring MVC you can ask for extra things if you need them? Right? Like you can just have these extra magic parameters and not part of your app, like servlet. So it's just like that. So here, when Embabel reads this, Embabel says, oh, you want the AI interface. That's one of my special things. I'll give it to you. But you also are clearly expressing a dependence on a domain model. You can only run your precondition as there is user input. And your post condition, expected post condition, is that there's a story. Then the next one is review story, which has an action annotation and also the add achieves goal convenience annotation, which says when you've executed this action, you've achieved the goal. It needs user input, the story, and also the AI interface. So we'll run it again and show the prompts, but let's make it a little bit more interesting because I do think it's kind of a little bit too feel good and sweet. Notice, by the way, we've chosen to raise the temperature here to 0.7, which means it's slightly wacky. So what we're going to do is we're going to be a bit cruel. We're going to set a trap for the story writer. We're going to raise the temperature to 1.2, which means it's probably going to be kind of silly. Like in general, OpenAI models go from 0 to 2. 1.2 is kind of a little bit silly. 1.4 is about where it'll probably spin off into some mixture of Python and C. But this will be, but then we're also going to get mean by changing the reviewer. So, so the reviewer, why don't we say, you will be given, consider with a story, okay, let's give this reviewer a persona. So here we've got a persona reviewer, professional and insightful. Persona is just a convenience class. It's a bit like what they do in Crew AI. Okay, so renowned, let's not confuse it with anything real. Let's say you are renowned for your cutting and acerbic criticism, that's Copilot. You do not tolerate mediocrity or cliche. Your objective is there are too many bad stories. Bad stories, we don't need more. Okay, so when we run this, we'll do a Star Wars story again. So if I do this, it should rerun the same command, and hopefully we'll get a better result. So what did it say? Yep, it's looking negative. I like it. This story, masquerading as a fresh Star Wars-inspired tale, is an exercise in blandness and cliche. The young pilot, the fabled weapon, and the predictable moral choice between power and peace are tired tropes recycled without flair or originality. So if we look at this output here, you can see the rather verbose planning output, which is the world state. Oh, by the way, since we have Star Wars, when it came up, it brought up this log message. This is something that I always wanted to do in Spring, but it was too late to retrofit, which is have all info level logging produced from listening to events, which is, I think, a really, really good discipline, because anything that drives the normal info level logging, you can pass over SSE, you can write an event listener that handles it. It's really very nice. So, but it also means that we get to, by default, well, actually, no, default is boring, but you can activate the Yoda, the Star Wars persona, just by setting Embabel agent logging personality. There's a few out of the box. There's Severance. How many people watched the Apple TV show Severance? The rest of you should watch it. It's like one of the best things on television for years. But sadly, you won't get our Severance logging unless you've watched both seasons. If you've watched both seasons, please turn on Severance logging. You'll love it. And so, yeah, literally all the things. So, for example, Yoda says, created a process I have. And where he says, created a process I have, difficult to see, always in motion is the future, ready to plan. So the planning is based on these pre and post conditions. Let's run it again, and this time we will, about Boston's history, we'll do the -p flag in the shell. This will show the exact prompts that go to the LLM. So when you create what we call an agent process in Embabel, it has a blackboard. So, you know, in order to plan these multi-step things, you need to have a blackboard. But you can also specify for the agent process the degree of verbosity on multiple dimensions, like does it show prompts, does it show planning, does it literally show log what you get back from the LLM. So if we look here, we'll also get a well-meaning attempt to breathe life into Boston's history, but drenched in cliche and pedestrian imagery. Okay, so let's have a look at what happened with these prompts. So it ran the first one, and here you can see messages, number of messages. So we've got a system message, and then we've got the user message. The user message directly came out of our code in the craft story method, right? So if you look up here at craft story, oops, this wrong window, craft, why am I looking at the integration test? Oh, we've got a testing framework, by the way. Craft story. So it's this prompt comes directly from here, the craft a short story, and obviously was interpolated. But some of the other stuff's a little bit interesting. So you can see the JSON schema that it's sending to the LLM to say what the type should be, something the framework handles under the covers. And you can also see in the system message the current date, and we should have somewhere the knowledge cutoff date. Maybe it does. Oh yeah, there, knowledge cutoff date. These are really important. By default, Embabel puts both of these things into every interaction. They're really important because LLMs obviously don't know the current date. They also don't know their own knowledge cutoff date. So, like when early on, working on Embabel, I asked through the API, asked about the recent Australian federal election. And it cheerfully told me about the one 3.5 years earlier, because as far as it was concerned, that was the Australian federal election. So in order to do that, you need to provide the date. So if you provide the current date, general knowledge might be good enough to know we have a 3-year term in Australia and there probably would have been an election, most likely. But if you give the actual knowledge cutoff date, it will be pretty sure that it really should check. Okay, so we also have, just logged the information about the hyperparameters. Let's show a slightly more complex example, because that really simple example did not call any tools. How many people know how tools use works with LLM? Okay, probably should explain it. So tool use is what makes LLMs useful. Remember when, even with GPT 3.5, it was like this amazing party trick that was really quite cool if you wanted to rewrite your essay in the voice of Hemingway, but it wasn't very useful for asking about anything fractional. You were purely reliant on its general knowledge and it can frequently hallucinate. So what we need to do in real applications, and indeed for virtually all uses of Gen AI, is enable the LLM to be grounded in reality. There's a couple of ways to do that. One way is what the first generation of RAG systems did, where retrieval augmented generation, where the LLM needs to be respond on something. So in the prompt, you put stuff that you think will help it respond. So the way you find that stuff is typically you use a vector search to a cheaper model, essentially to look for things it thinks are relevant. Or alternatively, if you know that somebody is talking to your agent about cancellation, you just put the whole cancellation policy in there. So it will definitely work to a degree, but is still not ideal, and you need to know exactly what it needs upfront. Tools were originally introduced by OpenAI, but are now supported by practically all models. And they're a different idea, which is much cleverer, which is that the LLM, rather than just returning to you its response, could come back to you and say, oh, you need to help me with something. So the classic example of this is the weather service. So if I ask an LLM what the weather is in Boston, it will have absolutely no idea. I mean, the best it could do was say, well, end of March, it's typically whatever it is. So imagine we told the LLM that when the user asks about the weather, I've got a function you can call, just tell me, and I will tell you what the weather is. But by the way, to call it, you need to tell me the location and the time. So I need to be aware precisely what you're asking. So the way in which most useful systems work today is they provide multiple tools to the LLM. And the LLM, for example, if it needs to look up a particular thing, if it needs to book something, if it needs to do anything in the real world right now, get current information, it will call a tool. So let's look at a simple example of tool calling in a somewhat more complex agent. So what this agent is going to do is it is going to take user input, try to parse using an LLM from user input the user's name and star sign. Then it is going to use good old-fashioned Java code to actually go and make a REST call to a horoscope service. And then it is going to come back to the LLM, build a prompt that says, this is the person, this is their horoscope today. I want you to go look up news items that are relevant to this horoscope. that might be useful in order to write something up for them. So these tools in this case come from MCP, but there are also other ways to get tools. How many people are familiar with MCP? Oh, excellent. So MCP is a kind of standard for tool calling. It has been pretty widely adopted, and it's certainly bootstrapped a pretty amazing ecosystem. If we have time, we can talk a bit more about other important alternatives. Okay, so what we're going to say is Linda is a Scorpio. Fine news for her. So remember, I described more steps. So we're going to need slightly more complex planning because it's got to work out based on the method signatures. Well, to make a write-up, let's have a look at the write-up method. To do the write-up, we need to have a star person, we need to have relevant news stories, and we need to have a horoscope. So it's going to have to work out a plan by which it can obtain those things. Okay, let's go. This obviously will take longer to run. So it's clearly executing the first call, which is trying to parse the star person out of input. It's now, I think it made the rest call. Now, it's calling tools. And we'll look at how that works in a moment. And at the end of it, we will, wow, it's, I think it's on the final one now. Okay, go on. Wow. Oh, no wonder that's slow. I don't know why this is set to use Sonnet. It doesn't need Sonnet. Okay, so Linda the Scorpio, mysterious as always. Today, even the stars seem to be playing coy. No horoscope for you. The horoscope service must be done. Well, and I guess, you know, one interesting thing about LLMs is they can actually reflect on bad things that happened. This probably is what happens when you have a demo that relies on somebody's horoscope service that you found on the internet. But let's look at how this worked. So the first thing that it did was extract star person. There are a couple of different paths in this. So extract star person needs the user input. It parses the star person. It uses, in this case, not create object, but create object if possible. So this actually, Embabel does an extra dance with the LLM to say, try to return this type. If you can't, tell me and tell me why. So it's actually nullable. And that means that you can potentially use a different route. So then the horoscope, this is an action that just invokes good old-fashioned code. You know what? If you can have a choice between doing something in code and doing it with an LLM, how often should you do it in code? 100%, because you can test it. It's by comparison, it's free. It's deterministic. So, you know, similarly, we could have given a horoscope tool to the next call. And I mean, to be honest, for the level of seriousness of an astrology application, I'd probably do that because I don't think astrology is deterministic. So like it's probably for this business problem, it's probably fine to do that. But nevertheless, you can see how in a really important business process, it's good to know we've absolutely guaranteed we've called the horoscope. In this case, it did fail, but you know, we are actually, if we're purely reliant on the LLM to manage many tool calls, we don't have control over the ordering. Whereas if you're breaking it up this way, you can ensure that what you wanted happened in the order you wanted it to happen in. Okay, so I haven't shown you the tool calling code. There's really two ways to expose tools in Embabel. The one is to specify a tool group. So you can, this is kind of a logical name. You can establish tool groups, and an Embabel server by default should have a web tool group where you can just say, I want these things. The nice thing about it being indirected by the name, as you could provide like Brave Search, DuckDuckGo, Google, or whatever. It doesn't break the code. The other thing that you can do is you can write tools from annotated objects or from an actual function. So for example, I could say with tool, foo tool, actually in Java you have to do new, don't you? Create class foo tool, and what we could, I think I did with tool instance. With tool, yeah, see, with tool object. With tool object, what this will do is take an annotated tool where you can do something like this. Okay. So this is not very interesting, but imagine that your tool class, your tool instance was a component. Imagine it was even a tool on an existing domain object that has state. So for example, a domain object has lots of state that it doesn't need to share with the LLM, but it's got some methods on it. So for example, it's a customer object, and imagine that in the context of a chatbot, you've got the need for that customer object to say customer requested callback or something like that. So you don't have to expose the state at all. You can just expose the state that needs to be communicated with the LLM while keeping critical state inside your application. So while MCP is really convenient for things like the search tool, things that look outside and work on the internet where somebody's written an MCP tool, if you're working in the JVM, which I argue you should generally write your tools in Java. Because guess what? There was recently that report that showed that MCP tools in Java were far faster than on other platforms if they're written in Java. How much faster are they if they don't go through the MCP machinery? If they're just like literally invoked. So Embabel gives you two ways of writing tools. You can do the annotated at LLM tool model, or you can implement the tool interface. The only reason that you would do the latter is if you need to dynamically create a bunch of tools, right? Like that are literally dynamic for the current user scenario. So tools are really important, and tools are a critical interaction point between your existing code and the LLM. And again, it comes back to thinking about domain modeling, thinking about what you already have and how you want to expose it. So because you're, in a Spring application, your Embabel actions have full access to everything in your application. You can get hold of domain objects, have tools on your domain objects, expose tools on your services, and you can choose as well which things are safe. Like I would be very, very skeptical about exposing as a tool anything that say mutates state. I would prefer to break that out into the action workflow rather than just rely on a tool call. Okay, let's now think about a few of the more advanced things that Embabel does. So Embabel enables you to write chatbots fairly easily. I mentioned the concept of an agent process. In Embabel, everything is modeled as an agent process, and a chatbot basically maintains an agent process for each conversation. So I think there's something really quite nice about that. One is that it's not chat specific. So that agent process just sits there, and what if it received an event that wasn't a user message? Fine, write a method to handle that event. So it gives you the ability to combine non-chat things with chat, which can be useful. So this is another Embabel template project called Erbot. And it's meant to be a starting point for your own chatbots. To be honest, it probably got a little bit out of control where it's kind of like almost a real chatbot, but it was originally meant to be like the simple starting point. But it's definitely a good resource if you're interested in chatbots. This is Varden. I love Varden. Yeah. It's all Varden. This is like most of our examples. It's also all Java, so it doesn't matter if you we're not going to force Kotlin onto you to learn to use the framework. So if we log in as Alice, we have a simple chatbot interface. By the way, if you're interested in Varden and building chatbots, we broke out all of the common things like the chat bubble and the user thing. There's a module called Varden Components that has all of that that you can use. So let's quickly have a look at how the chatbot works. So chat actions. This is an Embabel component, and it's got a respond method. Most chatbots have at least one method like this. So interesting things to note here is it's got can rerun equals true. Normally in an agent process, you run each action once and you get the type you want and you're done. Clearly, you're going to want to respond many times. Also, it doesn't produce an output type, so it just keeps running. But also, we've got this trigger equals user message.class. So it means that this method will be invoked if we already had if we just received a user message. Finally, we're not injecting AI, we're injecting another Embabel infrastructure class called action context. So all actions get an action context. Normally you want to specify operation context that's less specific, but action context allows you to send messages, which you probably want to do from a chatbot. So the interesting thing about this one is that it has memory, which I won't get into. But let's see where it gets the references for the user. So this is our Agentic RAG. So let's talk a little bit about RAG. So RAG is when you're interacting with your LLM, typically in a chatbot, and you've asked a question or are talking about some topic. And clearly we want to ground the LLM for that because we can't rely on its general knowledge. We may need up-to-date things. We need to be sure it's accurate. So first generation RAG was what was usually referred to as a RAG pipeline, which is we do some form of search and we shove the results of that search in the prompt. So for example, let's suppose I'm writing a chatbot for an appliance company. And the user asks, how do I clean my dishwasher? Well, I do a vector search around dishwasher cleaning and all the docs I've got, and I put the chunks that appear to be relevant to that in the response. There are a number of problems with that approach. And one of them was inherent in the term chunk. So clearly we might have documents that are hundreds or thousands of pages long. We may have many documents. We can't just shove the whole document in. We clearly can only shove part of it in. So when you vector index data, what you do is you break that data up into chunks and you embed that data in vector space. So embedding models are essentially language models. They're fairly large language models. They're not super large language models. They're much cheaper. They're much cheaper than LLMs, but they're still pretty big and complex. So what they're going to do is take every chunk of your document and they're going to say, no, that one goes over there, that one goes over there, that one goes over here in their vector space. So now when your user asks a question, you take the user input and the question and some of the conversation and you vector embed that. And it says, oh, it seems to be over here, kind of over there. And hopefully you get the right result. I don't know why. Oh, I think the power is... Yeah, the problem is power is not working. I think that's why it keeps. How much more? Oh, yeah, that might be. Ah, that's a good point. Yes, it's my problem rather than that. I can't stand. Stay. Ah, that's a great sound. So there are multiple problems here. One is that chunking is not a precise science. There is no way we can precisely chunk documents, right? If we had documents where they have exactly the same level, consistent use of sublevels, and there's the same amount of content in every sublevel, maybe we could. But that's not the real world. So therefore, typically we find that chunks end up being broken up and we've got breaks in the middle where, if we did what the embedding model does and said, oh, it seems to be over here, get a couple of chunks over there, they might be incomplete and make no sense. You can tweak chunk granularity, but then that means potentially you're putting too much in the context and that might confuse the model. So with Embabel, we take what I think is generally agreed to be the right modern approach to this. And again, if you find that you're being pressured to do Gen AI in Python, you might want to point out that, look, if you look at, say, how LangChain does it in Python, it's essentially legacy RAG because they've got lots of users back from 2023. Last time I checked their documentation, it really is nowhere near the cutting edge. The cutting edge is what is called Agentic RAG. And we did not invent it, but I think we probably have the nicest implementation of it. Agentic RAG works through tools because when we first encountered RAG back in 2023, tool calling wasn't a thing. The only thing you could do was use the prompt. Why is tool calling good? Tool calling is good because this is very specifically somewhere where you want to give your LLM a lot of agency. So let's suppose I am the LLM who is working for the appliance company and the user asks me, how do I clean my dishwasher? That's probably going to work because vector search is essentially conceptual, right? So yeah, it'll probably find resources on cleaning and dishwasher. That'll probably work. Let's suppose I say I have error code 09 on my dishwasher. Probably work because it'll get into dishwashers. Maybe it'll retrieve enough funds of code. Let's suppose I say I see 09, what do I do? There's no way vector search can work. That's not conceptual, right? That is something that could only possibly work through literal search for text. Obviously, one of the ways to solve that with legacy RAG is hybrid search, where you do like keyword search, BMI25 or whatever, as well as vector. But it's still always going to be imperfect because you are going to commit ahead of time for every query to the mix of keyword and vector weighting that you want. So imagine if I was that LLM and you said to me, you know what, you've got this other choice. You know how to call tools. I'm going to give you some tools and you can choose the arguments for your vector search. You can vector search again if it didn't work. You can use keyword search. Obviously, the results are going to be massively better, and they are better when it's agentic and you're just exposing tools to the model. Also, you can get away from the chunking problem with this. So we expose with any search operations implementation, and we out of the box we support PG Vector, Neo4j, Lucene, and any vector store supported by Spring AI. But you can also fairly easily implement that interface yourself, and you can implement as many of its sub-interfaces as you want. And the sub-interfaces can be like fancier things. So for example, can you find me the next chunk? That's really, really cool. Because let's suppose the LLM does a search, sees a result, looks pretty good, but it's clearly, getting to the really exciting bit and it got cut off, just goes back and says, give me the next chunk, that looked good. So, much superior approach. So the way in which we do this is very simple, and it uses a core Embabel concept called an LLM reference. An LLM reference combines a set of tools with what we call a prompt contributor. So you can build your prompts from strings, and you typically do. But if you encounter something where you want to reuse a particular thing frequently, you can implement the prompt contributor interface. So quite often, if you have objects that you're frequently finding are useful in building prompts, you can make those objects implement the simple prompt contributor interface, and then you can just drop them in really consistently. So LLM reference combines a number of tools with a prompt contributor. So it basically gives an additional piece of information on how do you use these tools, what should you use them for. So our RAG, Agentic RAG support is in what we call toolish RAG, and you give it a name and a description. The description is really important because you might have multiple of these things in the same prompt, and the LLM needs to be able to differentiate. And then you can optionally specify a metadata filter for like which parts of your corpus you're picking up, but you pass it a search operations instance. As I said, out of the box, you can have Neo, you can have Lucene, PG Vector, or a Spring AI vector store-based one, or you can implement your own. So then you simply, when you're going to use it, you just add, you can add like AI with reference or with references. In this case, it's done in a fairly fancy way. Let me see if there is anything that is actually ingested here. I think there might be some of Schumann's music criticism. Let's have a look. Okay, let's see what it does. Calling LLM GPT. It's looking in the user's memory, not going to find it. Now it's looking in shared documents. And this has retrieved stuff from an 1870 English translation of Robert Schumann's music criticism. You might ask, why did I choose that? Very important if you're testing RAG to find things that it can't get out of general knowledge. Like you can get a lot of misleading results where the result's pretty good, but you're not actually sure whether it came out of your corpus or came out of general knowledge. Let's have a look at what it did in the console. Okay, so the last response, this is set to be extremely verbose. And here we have the chunks. So here it's showing when it called that tool, it started by calling shared docs text search. So it decided that text search for Schumann and Meyerbeer was better than vector search. They're people, they're both composers, they vectorize pretty similarly. So that actually makes a lot of sense. And it apparently made a couple of calls because it wasn't completely happy. You can see here, this is the Neo query that it did. Actually, where is that one? No, that's full text search, not, yep. And it obtained this chunk, which it returned to the loop. And in this case, it didn't actually feel that it needed to expand the chunks, but if it had found a chunk that was cut off, it would have done that. This is a really long line, which is why you can't see the result. So let's now finish off before I take questions by talking about another couple of cool things that we do that I think are quite leading edge and very interesting. So tools, as I've said, tools are really cool. Problem with tools is that as you add more tools, the LLM gets confused. Also, as you add more tools, the context explodes, and that can be a problem. So a lot of systems encounter this problem. The one direction for solving that problem is shown by the agent skills spec with the idea of progressive disclosure. So we have a form of progressive disclosure, which I believe is unique for tools. So imagine that you've met our friend Toolish RAG. Imagine that you've got 5 different Toolish RAG instances. You've got product documents, you've got some documents that are specific to that particular user. It's not hard to see that you'd have multiple of those things. I think there's about 8 tools on each on Toolist RAG. So if you've got 5, you've now got 40 tools. So that's consuming a lot of context. But you've also got another problem, which is you would hope that your tools should have the ideal names. So now if you've got multiple sets of the same tools, you're going to have to put a prefix on it, which will use even more tokens, or you're somehow going to have to use different names. Our approach is, well, what if you didn't have 40 tools? What if you had 5 tools? And those tools were, for example, users documents, policy documents. And when the LLM knows it should need one of those things, it invokes that tool. What we do, and this is why we had to take over the tool calling loop from Spring AI, what we do is rewrite the tool calling history. So now the next invocation to the LLM has the children of the original tools. So this actually enables us to scale up to using a very significant number of tools without confusion or excessive token use. Again, if people think that Python is leading, I'm not aware of any Python framework doing that. And it solves a really, really important problem. And it comes back, I think, to the questions of the relevant skills. Like, application development and application framework development skills are different things from data science. And I think we have them pretty strongly in the Java community. One other thing that I'll conclude by mentioning, which I think is very important, is memory. Memory, 2026 is probably going to be the year of agent memory. Of course, memory should principally be exposed through tools, because I think in the modern world, most things you want to expose to LLMs, you should expose through tools. But I think there's a fundamental gap in how a lot of people in the Gen AI community talk about memory. Talk about memory like it's a greenfield problem. It's not a greenfield problem. In enterprise, what is a company's memory of its users? It's not really what the assistant typed in, like the last agent who spoke to them typed into whatever system they have. Most of the valuable memories about that customer are already highly structured. They're not in text. They're in Oracle. They're possibly in some SaaS systems, right? They're already extremely structured, and they're already things that the Java applications probably talk to. So rather than thinking about memory as a greenfield problem that we should solve purely by building up markdown files like OpenClaw does, we should think of memory as something that is grounded in what the enterprise already knows. So we have a memory module called DICE, which is still experimental. But what it does is attempt to link memories for agents with existing entities. So they have a much, much richer business context. Okay, I'll probably stop here so we've got time for questions. And I'm happy to talk more about any specific topic that people like.
You in Spring?
Not a little bit of Spring, not too much Spring.
Who chose the name Spring?
The name Spring was chosen by someone named Jan Karoff back in 2003. It was probably before the open source project. A community came together around my book on of the Rocks Press forums. And Jan and Jürgen were the first 2 people who really got involved heavily. Jan's biggest contribution was the name. He eventually had to cease contributing to the project because he said there were 3 things that were important in his life, and he could do 2 of them. And they were his girlfriend playing bass in a band in Spring, and he chose his girlfriend and playing a bass in the band. That was a good name. Yeah.
What about the name Embabel?
My younger child came up with the name Embabel. in the course of a road trip between Brisbane and Sydney. And I guess it was partly inspired by Douglas Adams' Hitchhiker's Guide to the Galaxy, the Babel fish, and I guess he, in turn, was inspired by the Tower of Babel. And we kind of like the idea in Babel. Sounds a bit like enable, particularly with the enterprise kind of focus.
I'm curious how your philosophy of breaking down a problem will work with problems that are not quite so decomposable. Your state machine is basically a one-shot thing. You go from A to N to get to your goal.
Yeah.
With, say, a chatbot, you have simply request response and something happens in between, but that is just one step of a multi-step process. So if you're trying to build a chatbot, it must guide the person towards one goal. It must have certain ways of talking and certain ways of coaxing the user. And now you're talking about a multi-step process, and where it seems to me I'm back to prompt engineering.
Chatbots are the one area where prompt engineering is unavoidable. With the best will in the world, you end up having pretty big prompts with chatbots, and it is harder to break things down. So what we tend to do is, where possible, so if we looked at the respond method in, well, chat actions, this kind of respond method here, one thing that we can do is put in scope an extra object if we realize there should be kind of a state transition, because the planning algorithm is greedy. It'll go for the most specific match. So for example, if you know you're talking about the customer's account, you could actually put the account in the blackboard and then it'll route to the one that has the account. So you can definitely get mileage out of that. But yes, chatbots are the area where to be honest, you get the least value from planning. However, what you can do is you can kick off sub-processes as tools. So imagine that you've got something that's really quite complex that you want to initiate from chat, and you want to know that's executed deterministic, like some kind of serious flow. You can give the chatbot a tool that actually wraps the agent, the Embabel agent that does that. So it's a nice way. It's what's often called the handoff or supervisor pattern. You're still reliant on the chatbot to call that thing, but you can ensure that the thing itself is as deterministic as possible. But yeah, like chatbots are important. They're probably not as important as I think a lot of people thought early in Gen AI, but they are painful. Babel will reduce the pain of chatbots, but it won't eliminate it. One thing that really can help, though, sorry, I'll come back to you. One thing that really can help a ton in chatbots, though, is the unfolding tools. The fact that, because chat, typically you don't know what the user is going to talk about, right? You might need a wide range of tools, and reducing the tool surface area works brilliantly. Sorry.
How would you reduce latency? Like, what would be some patterns for reducing latency if you have these AI-enabled apps?
Latency is a significant problem. So one thing you can do is try to use the smallest model for any given task. And, often I would say if you get no errors in returning a structured type, you're probably using too good a model. So you should definitely experiment around using cheaper models. But sometimes there is no alternative but to architect things in such a way that you get feedback to the user. If you are, so we have a progress tool where you can communicate with the user if we know where to find the user. So, you often just need to ensure that you're giving feedback.
for a specific problem, let's say like for solving using this method, like from problem we break down to goals.
Yep.
From goals to action.
Yep.
And each action will have like series of tools.
Actions typically have their own tools. So every time when you use the AI interface and say like with LLM, whatever LLM you want, at that point you have got something that you can add tools to. So every invocation, by default, you have to add tools to it. We did in very early versions of the framework, we had this fancy tiering where actions could inherit tools from their agent. And eventually we decided it was way better to be totally explicit and err on the side of no tools, unless the user asks. So I would say it is a really positive thing to use the least number of tools you can for any invocation. So an action can use 0 or more LLM invocations. So actions that just use code, that's totally fine. But you do find some actions that do more than one LLM invocation. One fairly common example of that is we've got a convenience method to run LLM invocations in parallel, and often you might want to do that. If you do that, you do need to set the concurrency, because what will happen is it will go faster until you trigger a rate limit, and then it'll go like that. So, for example, you might find with your LLM that you can execute 8 requests in parallel, but if you go for 10, you'll get rate limited and be backing off.
What are you seeing in terms of adoption of Embabel? Are there any large enterprise projects that have started using it?
Yes, there are. There's one in production, the one where they have a custom LLM at a very, very big software company. I think they've been in production probably about a month or two. I'm aware of a global job site that has stuff in production. Yes, there's definitely production usage. I mean, of course, with Gen AI as a whole, production usage is still relatively low compared to, say, I think, for this category of framework, the level of production usage is lower than it would have been back in the day. But I mean, we've also got a growing community, pretty active Discord community contributions. So yeah.
What's the cost for, say, enterprise support?
We haven't thought about that yet. I would imagine that it will be similar to normal other offerings. But yeah, I mean the software itself, of course, is Apache license. So there's no nasties lurking in there. We're never going to make anything out there already proprietary or anything like that. So, yeah, I mean, I think we understand that open source is about trust, and while we certainly might build proprietary products, that is quite separate from what we support in the community.
How can somebody get involved with your project? Are you looking for?
Yeah, absolutely.
QA?
We are very, very keen to welcome contributors. I mean, we've had some great community. Yeah, we've had some.
Golden opportunity,
I actually think it is.
Rod Johnson every day.
Yeah, no, everyone is most welcome to contribute. So we've had a number of contributions, including some really heavy lifting. But one of the things that is really valuable has been, there are with some LLMs, there's been little niggles with particular strange behaviors or the like. I think we've ironed most of them out. But, there's a lot of areas as well around the edges where people can contribute and eventually, if they want, contribute more to the core. But yeah, I mean, I think if you go to our GitHub, you'll see the developers and community are pretty welcoming. So they're happy to discuss things, and we discuss in the framework. We discuss everything in the open. So yep. Okay.
I was going to ask, any funny stories behind how you got started with this?
Not really. I guess the road, the road trip.
Yeah, one more about so I learned about Spring AI I think last June when it came out in version 1.0. So how much of Embabel extends upon Spring AI and is different from Spring AI or leverages it? Like, does that AI object or the AI class that you're using, is that from Spring AI?
No. That is Embabel. So the programming model is totally independent. So you can write an Embabel application without a single Spring AI import, and we would probably recommend you do. So a couple of reasons for that. One is, to be perfectly honest, Spring AI is not my favorite part of Spring. And if it was, Embabel probably wouldn't exist. So yeah, I mean, I was originally enthusiastic about, for example, the interceptor model that they have in Spring AI, and I have to say I don't think it's a tremendously good fit. I think the Embabel API is simply nicer. But as time went on, we discovered that we could do things like the unfolding tools, which I think are incredibly important, for which you need to totally own the agentic lab. So literally, I could write using the OpenAI Java library. I could write like Embabel support that requires no Spring AI for it in like 15 minutes. So it's just really incredibly low level what we're using it for. So essentially, they're independent projects. You don't have to depend on Spring AI to use Embabel. On the other hand, if you want to use them together, you can. And we do have people in the community who are doing that, who are probably strategically migrating to Embabel, but like have Spring AI stuff, and that works perfectly well to use them together.
I'm familiar that Spring AI has a vectorization service for
It does.
Java RAG.
Yep.
Does Embabel have that, or does that not even use that concept?
We do use that concept, but I think that vector search is really not sufficient. It's necessary, but not sufficient. So with the toolish RAG support, we support vector, keyword, structural things like chunk expansion. So if you have any Spring AI vector store, you can simply drop that in and you will get vector search with Embabel. However, having said that, vector search alone, Embabel vector search is agentic, so it will do better than the core Spring AI stuff because it will make multiple queries, but it's still it's not sufficient. So we have, for the stores that we support out of the box, we have our own vector support like Neo, Lucene. It's a query. Actually, you probably saw it's not very complex. Like if you look at this wasn't a vector search, but it was a keyword search. So this is Embabel issuing a text search to Neo, and the vector search just looks like that. So yeah. I also honestly I'm probably biased, but I'm also the creative Spring, so I probably have a right to opine on it. I would say if you're using Spring, Embabel is probably even a little bit more natural as an API than Spring AI.
So with Embabel built in Kotlin, will somebody programming in Kotlin have an advantage using that library?
Nope. Oh, well, it depends if you really like idiomatic Kotlin. Yes, you can do things like you can use the name parameters and that kind of thing. However, as I said, we put a lot of effort to make it nice from Java. And to be perfectly honest, when I write Embabel applications in Kotlin, I use things that are available from Java because they're just so damn nice, the things that we've built for Java. So no, not really. I would say, I prefer personally, I prefer Kotlin to Java, so which is why I choose to write Kotlin in the framework. I've written quite a lot of our applications, which are mostly Java. They're great. There's like using it from Java, there is absolutely no reason. Like, and honestly, if you look, say, at the Erbot application, which is pure Java, the Embabel usage in it is quite lovely. There's nothing really that would cause me to look at that and say, oh, it should be in Kotlin. Yeah, I mean, we're realistic about the fact that, you know, with Scala, I loved Scala, but even at the height of my love for Scala, I was very clear on the fact that if I was running a team of 100 people, I would not permit them to use Scala. Java would be a no-brainer. I think it's more complex trade-off with Kotlin, but nevertheless, most teams are probably going to make the choice that modern Java is right for them. And yeah, the experience is really good. Oh, by the way, in our documentation, which as I said is good, every single example in our documentation that's a code example has both Java and Kotlin and defaults to Java. So, yeah.
All right, one last question. No?
When's 1.0 coming out?
Probably at this point next month. It's pretty close. I think we will probably progress in spring convention to like milestones or even a release candidate pretty soon. Like I would say we're very, very close to a breaking change freeze. But yeah, we understand that like it is important in the Java community. We're not like, say, the Node community where they use 0.0.7 for in production. It is important to have a release, and I would say the API now is stable, and very shortly will be like frozen for backward compatibility. Great, thank you.